Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 42 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look. Down in the description, there is a link over to Amazon, and you can hop over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to give you a tutorial of how to incorporate a transistor into your Arduino project. Now, why am I doing this? When do you need to use a transistor? You need to use a transistor when you need to turn on or off a component that draws a lot of current or uses a lot of power. You can't control those, or you can't power those using your GPIO pins, so you need to incorporate a transistor. Now, why am I having a dedicated lesson on this? You see all over the internet tutorials that show you how to plug the transistor into your project, and they give you resistor values, but they never actually explain where those resistor values come from. So what I would like to do today is focus a little bit specifically on how the transistors operate and how you know what resistor values you should be using. Sound good? I hope it does. Okay, so let's switch on over here and let me get out of your way. And what I'm going to do is I need a project to sort of show you the need for the transistor and to motivate the use of the transistor. Otherwise, it's like, well, why are we looking at all of this? And so what we're going to do today is we're going to incorporate an active buzzer into an Arduino project. So the first thing you're going to need to do is find your active buzzer. So if you will get your Arduino Elite Explorer Kit in the top level, you will find this little bag. You can see that it has like a little piece of foam in it. So I need you to get that out. I'm going to make myself a little bigger here so you can see this. And you can see that there are two little barrel components on the end. You want the active buzzer is the one that has the little tab on it, the little white label. And so you want to get that one. Now, if your label has fallen off, you can also tell it's the right one, that the active buzzer, one leg is longer than the other leg. That other buzzer, both legs are the same length. You want the buzzer where one leg is longer than the other one and it has the little tab on it. That is an active buzzer, and that is what we are going to be using today. So jumping in and seeing, why would we want to use a transistor? Well, let's just start talking about this active buzzer, if you don't mind, because what we want is whoa, what is that? Okay, so let's try again on this. Okay, so what we want is we want the motivation. You know, why would we want to use a transistor? So let's think about that active buzzer, right? It was sort of a tubular shaped object like this. We had one leg that was longer and we had one leg that was shorter. Now, if I just came and I connected this long leg to 5 volts and I connected this short leg to GND to ground, this thing buzzes. So it's very easy to use. You just apply the voltage, and then when you apply the voltage, the thing will buzz. Now, immediately you might start thinking, well, let's come out from the Arduino and let's grab pin 8 on the Arduino, and then let's have it come over And let's connect that to the long leg. So connect pin 8 to the long leg of the buzzer, and then ground the short leg of the buzzer. And now if I turn pin 8 on or off, it would make the buzzer come on or off. Now that's kind of a straightforward way to think about it, but what you're going to see is if you did that, you would likely burn out your GPIO pin 8, and you would even possibly even burn out your whole Arduino. So why is that? Well, let's go in and let's look a little bit more about this buzzer. So if we look into this buzzer, what we will see is the buzzer, in order for it to buzz, it might use up to 50 milliamps of current. It might use up to 50 milliamps of current. I need to get out of your way now. At least I didn't cover it up, but let me get out of your way. And what do we know about the GPIO pins? The GPIO pins on the Arduino Uno R4. Remember, on the R4, they dropped the amount of current that you can source from the GPIO pins, and you can only source 8 milliamps. That's all you can source. But what the buzzer wants is it wants to draw or use 50 milliamps. So if you just came in and hooked it up in a straightforward way, very likely you would damage that GPIO pin. So how can we do that? We need something that can provide more current. Well, let's think about the 5 volt. Let's think about the 5 volt pin. The 5 volt pin on the Arduino. Now, if we look up that 5 volt pin, we see that it can source up to about 1.2 amps, 1.2 amps if you're powering the Arduino through that barrel jack, through that power plug, or if you're powering it through VN, it can source 1.2 amps. But if you connect it to the USB cable, the USB-C cable, you can power up to 2 amps. Okay, that's what it says. But what I want to warn you, I would never do this. I would never make an Arduino project that needed 2 amps and then try to power that through my expensive desktop computer and risk, like, what if I hook something up wrong and then I burned out my USB port or burned out something even deeper into the PC? And so I think that this is a very bad idea to try to power things that require a lot of current from your desktop computer. Just asking, what if something went wrong and you caused damage? And so when I am doing projects just for safety, just to be safe, I never like to draw more than 0.5 amps from the USB port. Does that make sense? You know how you've got your Arduino, you've got the USB cable, you plug it into your PC. I don't want a high power project powered through that USB cable because I don't want to take a chance of damaging my USB port on my computer. Okay, so what that means is that I could run this buzzer off of the 5 volt pin, and 50 milliamps is way below 0.5 amps, so I could safely do it. It's not going to hurt the 5 volt pin, and it's not going to hurt my USB port on my computer. But what is the issue? I can't turn the 5 volt pin on and off. It's not a GPIO pin. It is just 5 volts. So what is it that I need? I need a switch. I need a switch that a small signal, a small current can switch a large current. I need a small signal or a small current that can switch a large current. And what is it that will do that? How can we create that switch? We can create that switch with a transistor. We can create that switch with a transistor. A small current signal to the transistor will turn the transistor on and off, and the transistor can handle much larger current. So I have a small current or a small voltage turning on and off a large current. Does that make sense? I hope it does. Okay, so what I need is I need an electronically controlled switch, and that is a transistor. Now, there are two sort of core types of transistors, and each one of those two have two types. There's sort of like mainly four different types of transistors. So let's start at the high level. At the high level, you have a BJT. A BJT. What does that stand for? Bipolar junction transistor. And this would be an example of a bipolar junction transistor. This is what its schematic looks like. Okay, it has 3 leads on it. This lead is the collector. The lead with the arrow going out, that is the emitter. And then this lead in the middle is the base. Okay? How does this work? A small base current will turn the transistor on, and then you can draw a large current from the collector through the transistor out the emitter. So a small current turned on and off will turn on a large current in the collector emitter part of the circuit. Okay? The second type of transistor is called a MOSFET. M-O-S, all caps, M-O-S-F-E-T. What does that stand for? Metal oxide semiconductor, and then FET is field effect transistor. Now, this is how this transistor looks. Okay, the schematic is different. The leads come straight out like this. Again, 3 leads. This has a little arrow pointing in, like that. The arrow is pointing in. And this is the drain. The drain. This is the source. And this is the gate. Okay, now what is the difference between these two types of transistor? For this one, the base current turns the transistor on or off. Okay, the base current. In the MOSFET, the gate voltage. The gate voltage turns the transistor on or off. Okay, so the BJT transistor is a current controlled device, and the MOSFET is a voltage controlled device. And I'll get into this in a minute. But also, this is a specific MOSFET, and this is called an N-channel device. An N-channel transistor, and I remember that because the arrow here is pointing in. Okay, and over here on the BJT, the one that I have drawn here, is an NPN N transistor, an NPN transistor. Gate voltage on off. Okay, time for me to get further out of your way. All right, further out of your way. Now there's also a PNP transistor, and the PNP transistor looks almost the same. The PNP transistor looks almost the same, like this, but for the PNP transistor, the arrow is pointed in as opposed to pointed out. Okay, and again, I look at this, the N is pointed in, so PNP, it's pointing in, and the NPN, it's pointed out. And again, just like before, this is still the collector, this is still the emitter, and this is still the base, like that. Now this is the PNP. We also, on the MOSFET, we have the P channel. And how does it look? How does the P channel look? Well, it has the arrow coming out. And then again, this is still the drain. This is still the source. And this is still the gate. Okay, so what is the basic difference? What is the basic difference between these and these? These up here are much simpler. A positive current turns the transistor on, or for the MOSFET, a positive voltage turns it on. These down here, the PNP, it wants a negative current to turn it on, and the MOSFET P channel wants a negative voltage to turn it on. So to be honest with you, I never use these two types because it's kind of like you got to think backwards, and so I just don't fool with them. And so I will either use an NPN BJT transistor, or I will use an N-channel MOSFET. Okay, now today, for today's lesson, I'm going to show you how to use this one. For almost any project, either one will work. So I'm just going to show you one. I'm going to show you how to use it. Okay, now you need to get your transistor. We already, hopefully we already got our little buzzer. Hopefully you already got your little buzzer. And so now I need you to find your transistor. And your transistor is in this little bag of goodies, this little goodie bag that is in your top level of your Arduino kit. And then this is the transistor. And what you can see is the transistor is flat on one side, and then it's a semicircle on the other. Okay, it's flat on one side and semicircle on the other, and then it has three legs. Now, there are different transistors, so you've got to look with the magnifying glass and make sure that you are getting the S8050. And it's marked that on the little flat side. So if you look at the little flat side with the magnifying glass, you want to find the one that says S8050, because otherwise they look identical and you don't want to use the wrong transistor. You want to use the correct transistor. Now, the other thing I need to show you is I need to show you how the pinout works on these things. And so for the transistor, right, we've got the flat side, and then we've got the semicircle like this, okay? And notice how I've drawn this, or I've tried to draw this with the flat side pointed towards me. When the flat side is pointed towards me, the pin on the left is the emitter, the pin in the middle is the base, and the pin on the right is the collector. Okay, so it goes emitter, base, collector as you go left to right as you're holding the flat part pointed towards you. So let me just see if I can demonstrate that. So you see the flat part is pointed up, and so this would be the emitter, this would be the base, this would be the collector. All right, So now we have those. How do we actually incorporate one of those things into the circuit? So let's come back over and let's start with a clean sheet. So I will clear this. And now, how does this transistor work? Okay, we're looking at the NPN. So this is the collector, this is the emitter, this is the base, and then over here, if we look at it this way, just of the physical object, you have the emitter, you have the base, and you have the collector, like that. Okay, how does this thing work? Well, I'm gonna draw that more clear. I need to really make sure that you can see this. Okay, so I'm going to draw the transistor very carefully. I've got the collector, I've got the emitter, and I've got the base. Now there are 3 legs, so we have 3 currents. Coming into the base is IB, the base current. Coming out the emitter is the emitter current. And coming in the collector is the collector current. So the base current goes into the transistor, the collector current goes into the transistor, and the emitter current comes out of the transistor. And all 3 of those have to add up. And so what do I have? The emitter current, IE, that is coming out of the transistor is equal to the base current that is going in plus the collector current that is going in. So all the current coming in has to equal all the current going out. And so that's how those current levels work. But now, how do the currents relate to each other? Well, the base current is very small. It's down in the low milliamps. And then the collector current is an amplification of the base current. So how would I write that? The collector current is going to be equal to some amplification beta times the base current. Okay. Now for the S8050, the beta is equal to about 300. So whatever the base current is, the collector current is 300 times more. So I can have a very small base current switch a very large collector current. Now also, if we look at this, okay, if we look at the emitter current is equal to the base current plus the collector current, and the collector current is 300 times as big as the base current, we can simplify this equation by saying the emitter current is approximately equal to the collector current. Why? Because the base current is so small in this equation, we can just ignore it. All right, so now these are the 2 equations that will kind of allow us to understand how to do this. And I think I need to draw this up here again, kind of physically, put that back up there, just to remind you that the 3 legs are the emitter, the base, and the collector. Okay, so now let's think about how we would incorporate this into the circuit. So the pin 8 on the Arduino, that provides what? A very, very small current. And so we're going to run that through a resistor, and this is going to be our base resistor, RB. It's going to come into the base of the transistor, and then up here in the collector, I'm going to put my buzzer, and then my buzzer is going to go to 5 volts. So the buzzer is going to be connected to 5 volts. Remember, the 5 volts needs to go to the long leg up here, and then the short leg is going to connect to the collector of the transistor, and then the emitter of the transistor is going to go down to ground. And so as I give a little current on the base, I'll get a large current in the collector, which can turn the buzzer on. But what is the value of this RB? How do I calculate the value of RB? Well, let's look at it this way. What do I want for the collector current? The collector current, we said we don't want it to be over half an amp. So let's just do the analysis for half an amp collector current, and then we will choose the resistor that would give us a half amp of collector current, because we don't want it to be any more than that. So we want to limit it to that. So the IC, we want to set that to a 0.5 amp max. 0.5 amp max. Now, what else do we know? We know that the collector current is equal to beta times the base current, and we know that the collector current that we want is 0.5, and we know that beta is 300, and therefore that's multiplied by the base current. Now what can we do? I can calculate the base current that I want, and that's going to be 0.5 divided by 300. Let me put that in my calculator real quick here. 0.5 divided by 300 is going to be 0.000017 amps. So to make sure that I don't burn anything out, I want the base current to be 0.0017 amps. That is also the same as 1.7 milliamps. Okay, what is the maximum current that the GPIO pin can source? It can source 8 milliamps. So if I'm drawing 1.7 milliamps, I'm safe. The 5-volt pin can draw, we said, an amp or two, but we're going to limit it to a maximum of 0.5 amps, and so that is safe too. I'm not going to damage the 5-volt pin, and I am not going to damage the pin 8 that I'm going to use. So what I want is I want a 0.0017. Now what I've got to do is I've got to look over here at this transistor circuit again. So this pin 8, we're going to have the pin 8 at 5 volts. So that's pin 8. Now we're going to come through this resistor, and then we're going to come to the transistor, and then this is going to go to ground, and then this will go up to the buzzer. All right, so now the question is, what value of RB do we need in order to get 1.7 milliamps? I've got to choose an RB. Well, what is the voltage drop? What is the voltage drop across this resistor? Well, we know that the 5 volts, we know that we start with 5 volts. So I've got the 5 volts is going to be equal to the voltage drop across the resistor. The voltage drop across the resistor, I'm starting here, and I'm kind of driving around. So I start at 5, and then I'm going to have a voltage drop across the resistor, and then I'm going to have a voltage drop across the transistor, a voltage drop from here to here. That is the base emitter voltage drop. And we know that the voltage between the base and the emitter on an NPN transistor is about 0.7 volts. Okay, so now we're getting close. 0.7 volts. Look at that. No matter where I go, I end up in your way. So the 5 volts that is coming out of pin 8 is going to drop across the resistor and across the transistor, but what drops across the transistor is 0.7 volts. Then if I subtract 0.7 from both sides, I can see that the voltage drop across the resistor is going to be 4.3 volts. Now, what do I need? I need to calculate what resistance. Well, the voltage 4.3 volts is going to be equal to the current. What did we say the current needed to be? 1.7 milliamps. The voltage is the current times the resistor. Okay, and that's going to be resistor B. So now resistor B, if I divide both sides by 1.77 milliamps, that would be 4.3 volts. I'm going to have to get even smaller. The resistor is going to be 4.3 volts divided by the 1.7 milliamps, and we need to put it back in amps, and so that would be 0.0017 amps. And therefore, if you put that in the calculator, RB is going to be equal to 4.3 volts divided by 0.0017 amps, and that is going to be 2,500 ohms. So what does this mean? This means that in this circuit, if I choose a resistor of 2,500 ohms, then that means that the IB, the base current, is going to be 0.0017 amps, which is going to be safe. And then the collector current is going to be 0.5 amps, which is safe. Now, if I turn pin 8 on, I get this current, and I get a buzz. If I turn the pin 8 off, there is no base current, so there will be no collector current, and so the buzz will be off. Okay, is this painful for you guys? Why am I doing this? Because every time I do a video, somebody asks me, well, why did you use a 2,000 ohm resistor? Well, you can see that if I use a 2,000 ohm resistor, my pin 8, my GPIO current is going to be below 8 milliamps, and my collector current to run the buzzer is going to be less than 0.5 volts, less than 0.5 amps, and that's more than what I need to run the buzzer, which is like 50 milliamps. So now you know why I am going to use a 2,000 ohm resistor. Now, I think I said 2,500. I came up with what was the exact number that I came up with? 2,529 was the exact value. But since I have so much margin, the closest resistor in the kit is 2,000. So instead of 2,500, I'm going to use 2,000 ohms, and that should work. Okay, so let's see if we can hook this thing up now. And if you guys are frustrated with me going into all this math and all this engineering, I'm doing it because every single time that I do one of these transistor projects, invariably someone always asks me, well, why did you use a 2,000 or a 10,000 or a 5,000 ohm resistor? So now you know. Okay, so what do we need to get? We need to get our active buzzer. Okay, and then what else do we need to get? We need to get our S8050 transistor. You need to get your 2,000 ohm resistor from your kit. Okay, and this up here says 1,000, and that was just the generic value. But when I actually went in and we did the calculation, we're going to use a 2,000 ohm resistor because that's really the value that we get when we do the calculation. Okay, so now let's see if we can get this thing hooked up. So remember we said the long leg goes to the positive voltage, and so I'm going to plug this in, and you can see I have a little wire there. But the short leg is going to connect to the end of the wire, and the long leg is going to point to the right. Okay, so let's see if I can get that. It's actually kind of hard for me to see. Okay, so the short leg of the buzzer is connected to this wire, and the long leg of the buzzer, where do we want that to go? Well, if you look up there, we want that to go to 5 volts. And so I'm going to come over here. I'm going to grab it there. And then you can see here is the 5 volts. Here is the 5 volts right there. So I'm going to plug that in. Okay, now I'm going to go ahead and I'm going to plug in my ground. Now let's go ahead and work our way through. So we've started at the top. We have the right leg, the long leg of the buzzer hooked up to 5 volts. We've got the short leg of the buzzer, and we want to connect that to the collector of the transistor. Well, where is the collector? Remember, when the flat spot is pointed towards you, when the flat side is pointed towards you like this, the collector is going to be on the right, and the base is going to be in the middle, and the emitter is going to be on the left. So the right pin, like this, is the collector. So I want to put the collector right like that. Okay, so where did the collector go? The collector goes to the wire that is connected to the short leg of the buzzer, just like over here. The collector goes to the buzzer through that wire. Now the center leg is the base. The center leg is the base. The base is going to go from through a 2,000 ohm resistor, because that's more appropriate than what was in the schematic. And then on the other side of that resistor, we are going to connect to pin 8. So I'm going to come over and I'm going to connect to GPIO pin 8. You see that? GPIO pin 8. Okay, GPIO pin 8. Now, what do we do with the emitter that is on the left? The emitter in the picture just simply goes to ground. So I'm going to come in, and on that left transistor pin, the left transistor pin, I'm going to come down, I'm going to hook that to ground. Okay, do you see how that black wire is connected to the ground? All right, so now that is all connected. All right, now we need to come in and we need to code this thing up. All right, so let me see if I can get this a little bit straighter and a little bit easier to look at. I think now I will just turn my schematic off because we have it hooked up now. We'll move this over here where you can see it a little better. And now I think we're ready to start coding. So let me come over to the code view, and I think you'll be able to see that. Go ahead and open up a brand new bare minimum, okay, because this is going to be pretty straightforward to code up now. All right, so we're going to declare our variable. So I'm going to say come up to the top, and I'm going to set up as an integer my buzz pin, and my buzz pin was equal to pin 8 is what we connected it to. All right, and now in the void setup, I need to do my pin mode. And my pin mode is going to be what? Buzz pin, and it's going to be an output pin. like that. So I've declared my variable, I've done my pin mode. Now what do I want to do down here in the main code? Well, it is going to be, I also need to up here, I'm also going to int a DT for delay time, and let's just make that 500 for 500 milliseconds. That'll be a half a second. Now I'm going to come down here and I am going to, let's see, Control T gets things lined up kind of nicely. So I'm going to do a digital write what buzz pin, and what do I want to do? I want to set it high like that. All right, and then I'm going to delay. How long am I going to delay? By delay T dt. All right, in the semicolon. Now I'm going to do a digital write, and then what I'm going to digital write buzz pin, and then I'm going to make it low like that, semicolon, and now I'll do a delay dt like that. All right, so I'm going to on for half a second, off for half a second, on for half a second, off for half a second. Okay, could it really be that easy? Could it really be that easy? Let me look. That looks pretty good. That looks pretty good. Let's go ahead and run this thing, and it's looking good, looking good. Okay, looks like it is downloading, and boom. Can you hear that? Let's make sure you can hear it. Okay, do you hear it? All right, you can see that it's not very loud. So what I'm going to do is I'm going to show you guys a pro tip. Okay, do you see this label on here? The purpose of this label is after they have made the device, they have that label so they can wash it without the cleaning fluid getting down in the buzzer. But after it's washed, it's not needed, so we can take that off. Ow. And we have a booming buzzer. We have a booming buzzer. All right. So you can see that is really, really, really loud. So in fact, it is so loud that I am going to just see if I can download this to a different pin just to get the thing to go off. Okay, so that went off. So let's come back over here and let's kind of recap. Let's recap what we did here. Maybe this would be a good thing to look at here. We'll look at this. So we have got the transistor. The transistor turns on and off based on a very small base current. A base current of a milliamp will turn that transistor on, and then it will draw a very large current, 300 times. So the collector current coming down through the buzzer will be 300 times as large as the base current. Okay, so the base current is small, and then the collector current is large. What does that allow us to do? It allows us to use a GPIO pin, source a small amount of current, and then turn something like a buzzer or other large current device on and off. So we are controlling a large load using a very small signal. Okay, hopefully that makes sense. Now, you would also do something like this, but you might see the motor. You might see the motor in your kit. And what I want to say is, though, don't come in and just take this out and put the motor in, because the motor, yes, it draws a lot of current, but it also acts like an inductor. And if you go in and just start trying to turn the motor on and off without doing a little bit more circuit design, that impulse current from the motor could actually come back and burn out your Arduino. And so you want to wait till we show you how to do it, but a lot of it will be the same concept. We will be controlling a large current that runs the motor from a small current on the Arduino GPIO pins using a transistor. Okay, guys, I really want your feedback on this, because as we were going through the math, and we were going through the transistor operation, we got into a lot of details, and this might actually be one that you'll want to come back and listen to again. But if you go through it carefully, you can see that I very deliberately designed this thing so that we don't damage the 5-volt pin, we don't damage the GPIO pin, but we can get enough current through the buzzer to actually make it work. So go back and watch this one again if it doesn't make sense. But you are the guys that ask me every time about where those resistor values come from. And so today I just wanted to kind of go through it in detail and show you how you can incorporate a transistor now into your Arduino projects. So what you guys can do, you can play around with this, and you can just sort of show that you were able to get your buzzer working or your component working. And then what we'll be doing is, in future lessons, we'll be looking at other areas where we might need to be using a transistor. Okay, guys, I hope you are enjoying taking this class as much as I am making them. As always, at this point, I want to give a big thank you to you guys who are standing with me on Patreon. It is my Patreon support that enables me to continue week by week making new videos. Thank you guys for the support. Also, you can help me by giving me a thumbs up and leaving a comment down below. If you haven't already, make sure that you subscribe to the channel. When you subscribe, make sure that you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.